Neural network modeling for risk management. Neural network is a very powerful, versatile modeling tool. In this video, you will learn how to develop neural network models and analyze performance of models. We will also make use of database system in this process. This video is organized into 4 sections. Section 1 is network configuration. Section 2 is network training. Section 3 is applying models to database. Section 4 is analysis of model performance.
Section 1. Neural network configuration. The first step is to open a dataset. We will use the German credit data which is available from the UCI machine learning repository. In case of insurance, use insurance claims data. Modeling process is still the same as credit data. To open a dataset, click the Dataset tab. And double-click the German credit dataset. Next step is to create neural network model and configure it. Make sure your dataset is in the front of the main panel. To create a model, click the Neural Network button of the toolbar. Now you need to select a set of induction fields, also known as independent variables. We will use all the fields, except target fields. In practice, you should use variables which have high relevancy through variable relevancy analysis. For information on variable selection, please read the document. Modeling Guides for Neural Network. Then enter Hidden Layer Node Configuration. This specifies how internal hidden layer nodes are organized. Normally this would range 3 to 15 nodes of a single layer. In this example, we will use 7. This generates a single hidden layer with 7 nodes. Note that the number of hidden layer nodes corresponds to the level of detailness of learning. More means learning is more detailed but less general. Less means less detailed and thus more general. Too many nodes can lead to overfitting, which means model can predict accurately on training dataset, but is not accurate on unknown data. So the selection of hidden layer node size is very important. Select an activation function. Normally, logistic function is the classic choice, but hyperbolic tangent plus can sometimes train faster. We will choose logistic function here. Select decision target. Decision target is the dependent variable. It is the predicting values. When a categorical variable is chosen, this will become a classification model. When a numerical variable is chosen, it will become a numerical value prediction model. Note that classification models tend to produce lots of false negative and false positive predictions. It is not accurate on unknown data. Scoring methods are better. Scoring methods predict risk levels between 0 and 1 proportionally. So we will use the numerical target variable risk flag. Finally, press the Create button.
Section 2. Neural network training. Now you are seeing the initial state of a neural network model. Until it is fully trained, this won't do any good. So next step is to train the network model. While the model is in front of the main panel, press the Neural Network button again to get the training dialog window. Select a training dataset. Note that training datasets should be opened in the main panel before this dialog window. CMSR will automatically bind to the first dataset opened in the main panel or to the dataset used in configuration. Check the binding of independent variables with the training dataset. Network training is repetitive process. You can repeat training any number of times. You may also use different datasets for different repetition. Choose a number for repetition. Then press the Train button. This may take a while depending the size of data and the size of network. You will see the network evolution chart showing accuracy transition. Blue line shows the current best accuracy. Red line is the current accuracy. Repeat training until the best accuracy does not improve. There is no risk for overtraining, but undertraining may lead to less accuracy. You may need to lower the error correction ratio, which is the training speed. It is the first parameter of the adjust options. If running accuracy saturates or fluctuates, lower this error correction rate. and train again. This process is called incremental training. Stop training when the best accuracy does not improve significantly. Once the model is trained, press the Cancel button. It is recommended to save models after training always. Saved models can be reopened and retrained using various datasets. To save model, press the Save button of the toolbar. Then enter a model name. Press the OK button. It will be added to the current project model list.
Section 3. Applying model to database. Next step is to apply the model to a database table to analyze performance of the model. In this process, the model will evaluate values of the database table and store results on a selected column of your database table. This process will require a database table column that will be used to store predicted values. To create a database table column, select the database which contains your testing data. Note that database should be logged in. If not, double-click the database and log in. From the database menu, select SQL. Then enter a SQL statement to create a database table column. We will use Model 1 score as new column name. Then press the Apply button of the toolbar. Press the Confirm button. Now you can use this column to store model evaluation values again and again. No need to create again. To apply a model to database, select the model. That is, make the Model tab at the front. Then press the Apply button of the toolbar. The Apply button will be enabled when both a database and a model are selected. Choose a model version. Choose a schema name of your table. Choose a name of your table name. Choose a store field. This should be the Model 1 score column we just created. Record identifier is a column that uniquely identifies each record. Note that this column must be indexed or be the primary key of the table. We will select the record SEQ field. Then make sure input fields have correct database field names. If database column names use the same names as in the model, CMSR will automatically select correctly. Otherwise, choose manually. Finally, press the Apply button. This may take a while depending database table size.
Section 4. Analysis of model performance. In this section, we will use scatter plot and histogram charts to analyze model performance. This is also called model validation process. First, we will use scatter plot. To draw scatter plot on predicted values from application of the model into database table. First, select a database. Then from database menu, select scatter plots. Select the schema name of the database table. Select the database table that contains model application data. Then select independent variable as record SEQ. This is the column that contains sequential record numbers. If your data has no such column, it is recommended to create a sequential number column. Record sequence numbers are 1, 2, 3, 4, 5, etc. This will ensure samples spread evenly in scatter plots. Choose dependent as Model 1 score. This is the column that contains model evaluation values. Select category as risk class. This is the categorical variable that contains target class labeling information. Then press the Draw button. Except some mistake samples, bad ones are congregated around at the score 1 line. And good ones are clustered near the score 0 line. Note that bad ones are colored in red. Good ones are colored in green. Scores range between around 0 and around 1. Higher scores means higher risk. Lower score represents lower risk. If we use a higher number of hidden layer nodes in configuration, mistake samples can disappear. But this may result in overfitting. Notice that you don't see samples in the middle scores. This is because the MCI data used in modeling has boosted data to make decision tree classification works. It's a fabricated data. Boosting made outliers as statistically significant patterns. If you use real data, you would expect mixed good and bad middle score samples. Next step is histogram analysis. To draw a histogram, as usual, select a database. Then from database menu, select histogram. Select the schema name of the database table. Select the database table that contains model evaluation data. Choose value as Model 1 score. This is the column that contains model evaluation values. Select category as risk class. This is the categorical variable that contains target class labeling information. Then press the Draw button. As in the scatter plot, you can see bad ones colored in red are congregated around at score 1. And good ones colored in green are clustered near the 0 score. To see categorical ratios of each slots. From %. Choose categoric proportion. Now you can see overall pictures more clearly. Analysis techniques introduced in this section is very important in understanding models' predictive patterns. This is to make sure that your model will predict risk levels correctly. Depending on this analysis, you may need to develop another model with more or less hidden layer nodes and train and analyze again. This process should be repeated until a good model is reached. This will end this tutorial video. For more information, please read the document Modeling Guides for Neural Network and RMEEP Deep Learning Guides for Advanced Topics. The documents are available to CMSR Studio users. CMSR neural network modeling tools are very powerful and advanced. Still very easy to use. Thanks for watching.